Welcome back friends to my series of practical machine learning, and currently we are learning supervised machine learning through hands-on introduction. In my previous lecture I introduced to you how supervised learning classification works by doing hands-on on student performance prediction, where we classified performance in two labels as pass or fail based on study hours. And what we did, we made use of earlier existing labeled data where students were pass, fail marked according to their performance, and we had to predict on new data. Now in this tutorial, what I will be doing, I will be talking about another kind of supervised learning problem, and that is regression problem. And in regression problem, what we will be doing prediction of a continuous variable. So continuous variable is any variable which can have any numerical value, right, between 0 to infinite. Why supervised learning? Because we will be making use of labeled data. So without further ado, let's get started with the practical problem, and I'll be moving to my Google Colab to get started with the problem. So friends, I'm at Google Colab and I have already imported the data which we need for this problem statement of salary prediction. I have also imported basic libraries which we will definitely need, and we will more libraries as and when we need. And we know the important libraries are pandas, which we will be using to import our data CSV into data frame and then manipulate and visualize data. And then matplotlib and lib is a basic library for data visualization in the form of graph, and cbond to make graph look more interactive. Let's see this problem data first. So this is our data, and as we can see, there are just two columns over here. One is salary, the other is years of experience. Salary is a dependent variable or a target variable which we are supposed to predict on new data. Then years of experience is independent variable or feature. So this is supervised learning, as I said, because we are already given this label data. Our model will be learning from this data, and when new data is provided to the model, it should be able to predict salary for the given year of experience. Now, how this problem is different from the previous problem which we did for classification. In our previous problem, we were given, let's say, 3 columns over here, and our target variable was pass fail, and study hours and previous exam scores were independent variables or features. Basic difference, so both are supervised learning. The basic difference between them is the nature of the target variable which we are predicting. Pass fail has limited values, in this case only 2, and hence this is also called binary classification problem. In case there are more than 2 but limited values, that is multi-classification problem. So this is the problem of supervised classification. While the problem which we are going to do now is a problem of regression, supervised regression problem, where we need to predict salary, which is a continuous variable. It can have any numerical value. Coming back to Google Colab, what we have to do as a first step is to load and validate data. At this point, I would encourage you to use keyboard and finger and get along with me, not just by watching the video. So first step is load and validate data. So what we do as part of this, we create a data frame variable, and with the help of pandas read underscore CSV, because data is in the CSV, we'll be reading CSV. So we have to first run this, and then we have to run this. Once we have this, let's validate that our data is loaded correctly, and that we can do with the help of df.head, which gives us the first 5 rows of the data. And as we can see, this data has the same number of columns which are indexed by pandas. The other thing which we talked about in our last tutorial is that panda automatically assigns the data type to the variable. And as we can see, years of experience is shown as float because it has some decimal values. It has decimal values, while salary is shown as integer over here as picked by pandas. Now sometimes panda can pick wrong data types also, and that we need to do clean up as part of data processing, and we will be talking in length over our upcoming tutorial. But this years of experience salary data type is this, and there are total 30 records in the data set, and all are non-null in nature. Now let's proceed to exploratory data analysis, and as the name says, we will be exploring data, but not just in any direction. What we are supposed to do, we are supposed to ask some business questions and come up the visualization of the data and the statistics. This can also be in direction of modeling, where we need to explore what features are relevant, which we will again talk in length in our later tutorials. So for now, let's just explore a couple of things. And the first thing is, what is the distribution of data, which we can do with the help of df.describe. And I have already talked about these statistics and I'll be talking about them, but in detail you can have a look at my tutorial on statistics. As we see, years of experience, salary, the count, as the name says, total number of values, mean of those values, what is the standard deviation of the value in that, and what is the minimum value, and so on. So if you see over here, the standard deviation in salary is quite high as compared to year of experience, and for that, if we see minimum salary 37,731, while the maximum salary is 1,22,391, and so there is a vast difference in salaries. And again, the scale is also different in case of year of experience and salary, and the minimum here is 1 and the maximum here is 10, and at any point the middle value, which is median, is this. Now let's have a look at distribution of salary, which is our target variable, and the appropriate graph for that is histogram, right? Distribution, and we will be using SNS.histplot, and we'll be passing the variable df salary. And as we can see, this is the distribution. We can use another argument over here, which is KDE is equal to true, which is kernel density estimation, and it plots, it helps in smoothing process, and we can get the shape of the distribution with the help of this. And with this current data, this is the shape. Right now we can see that peak value or mode is of salary is lying between the range of 50,000 to 70,000, something like that, and we can see the data. And the minimum salary count is minimum at this point, which means that minimum number of people have the salary range between 70,000 to 80,000. Since this is hypothetical data, we will not be talking in detail about this more to arrive at any conclusion. This is just a way to visualize our data, and the appropriate graph is histogram. Now, in case you want to see the relationship between year of experience and the salary data, both of them are numerical in nature, we will be making use of scatter plot. Okay, relation between year of experience and salary. So SNS or scatter plot, x is equal to df, y is equal to df. And friends, you need to do this on your own to get a hold of it. Otherwise, if you will just watch and think that it is very easy to do, we will not be able to do on our own. Okay, here's the plot. Now we can also make use of something called reg plot over here, and let's see the difference what it gives. And as we can visually make out, there's linear relation, and that is so obvious, between year of experience and salary. Positive correlation between salary and year of experience, that as the year of experience increases, salary increases. Let's move to our next task, which is ML modeling. And what is the purpose over here is to predict the salary on the new data. That is, whenever any year of experience is provided to the year of experience is provided to the model, it predicts the salary. So even before we go for modeling, we know there is a very crucial step in between the process before actual modeling, and that is data pre-processing. Right now, since it's just the introduction of regression, we'll not be doing much about it, but just couple of things, which is breaking the data into target, variable and feature, and then splitting the data into train and test data. Okay, so let's go for data preparation. And as part of data preparation, we need couple of libraries. We'll be just importing from sklearn.model selection, import train, let's go test split module, so which can help us to split the data from. So first thing first we will break it into target and feature. So machine learning model needs to know what is the target and feature for learning. We represent feature set with the help of capital X, target with the help of capital Y. In this for getting just feature columns, we have to drop the target column. So we will say df.drop column is equal to salary. Similarly, to get the target variable, we have to just get the salary variable. And let's also see the data types of X and Y. Print Y. Print. So let's run this. Oh, I printed X and Y itself. So anyways, so as you can see, X is again indexed value with the, since we have only one feature. Otherwise, if we would have more feature, it will show that. And then we have the values, indexed values of Y. What I wanted to print is a type. So let's see that. And as you can see, it says first is data frame and the other is series, since it contains only one column. And let's do the train test split now. To do the train test split, we need to write x_train, the value of features which are going to training data, and then the one going to test data, the value of target variable which is going to train data, and the one going to test data is equal to train_test split. Pass the value of the ones which are to be splitted along with how much ratio should go to the test size, and I say 0.2, which means 20%. And then I will give random_state, which I explained in my last lecture also, is just the value of any number, and it helps in reproducibility of the same data set. And there are more arguments also in train test split, which we will talk later, just to keep it simple over here. And let's just run this once, and then we'll come over here. We already ran that, and then this. So our data is splitted into train and test data. And why we do the train and test split, this also explained in my last lecture, is because we want to keep intact the data, test data, as unseen data for the model, to validate the performance of the model at later stages. If we would use all the data in making the model learn, at the end we will not know how is our model performing, because we have no proof, right? So we will just feed train data. Now comes the important part, and that is the first and the basic algorithm which you need to know from heart, and I'll be explaining in detail in my next tutorial about how it works, is linear regression model. And important point is that logistic regression is based on linear regression model, and how we will again see in our upcoming tutorial. We will be using the basic linear regression algorithm over here to create our model, and so we need to import it. Alright, let's run this and let's create an instance of this model. Call it model, okay, for now. And we are creating an instance so that we can access whatever methods and all are available in this class. Alright, so we have a model and it is ready to learn. And to make it learn, we need to feed the data. So we will proceed to model.fit, where we are training our model so that it can come up with the relation between feature and the target variable on the basis of the data provided. And since it is linear regression model and we'll be talking about it, it will come up with the linear relation between feature and the target variable. So let's run it. So we have our model trained over. It's as simple as that, right? And what algorithm goes behind it, I will be talking in very, very simple terms in my next tutorial. Let's see how it is working in practical over here. And let's predict the value of the variable. What we want to predict is that we have kept intact this x_test over here, and we will give it and we will ask a question. Now tell me what is the salary, and we already know that. That's clever, right? So we say that model dot predict and we pass to it x_test. See, we are hiding the value of y_test from the model, and we are asked like a teacher ask the question from the student while hiding the value of the answer, just to check if the student knows the answer or not. And we will run it, and now is the time to validate. And how can we validate? First thing first, we know what is, let's say we will just say, okay, I know what is y_test, and maybe I want to see the first couple of values, and I'll just run this. So it says these are the first few values of the salary, okay, and which is 1,12,635 and then 67,000 and so on. And let's see what our model predicted for the same set of data. And we can say y_predict, which we already have, and we'll fetch the same number of values for the same set of data for that. And you know what it gives? It gives 1,15,790, 20, then this is 71,000 something, then so on and so forth. Not bad, right? I would say we have not done much of pre-processing or anything over this, so it's just good. We will say just fine, okay? And let's see how we can validate more about this. Now, the first question which comes to my mind is how we can validate the performance of this data is by giving a simple example. Let's say you ask your student that what is, 5 multiplied by 2, right? And the answer comes up at 11, right? And you know that the answer is 10, and you ask another student what is 5 multiplied 12. So what you are basically doing, you're coming up with the difference in the values to come up with the error, right? Delta that model is coming up with, to see that how accurately that model is predicting. And that's what we will be doing as a part of coming up with the performance evaluation matrix. The important point to note over here is, like in back there in classification problem, our criteria was different, right? For performance evaluation, that was how many records are correctly classified. But here the criteria is what is the difference in the value of the continuous variable, which is the actual value, and which is the predicted values, right? So that is getting interesting, and let's see how we can do that. Let's write performance evaluation. Now, this is not the typical way we will be doing evaluating any model or linear regression model for that case. And we have sklearn matrix module available, and what we will be doing, we will be arriving at the matrix on the basis of our intuition. And our intuition is that the error is the difference in the predicted value and the actual value, and let's just create a data frame. Okay, so the how we can create data frame by itself by using panda library, of course, and let's call it as df_result. And these steps are just to arrive at how we are calculating the result and are not normally done in any modeling. We will do pd dot data frame, and then to this we will pass a dictionary. Let's say we have predicted value key, we pass the value y_predict, and similarly we have actual value, to which we pass test value, actual value, the values from the test data set, and the y predict is the one which we predicted for x_test. So we have this data. Let's just run for now. We'll see that we have got a data frame which has two columns, predicted value and actual value, and let's create a couple of more columns. So the third column which we can create is, let's say, error value, and to this we assign, as our intuition says, the difference between test value and predicted value. Now the interesting point to note over here is how we can subtract in one go all these values, and that is due to NumPy arithmetic operation. And this, as we saw earlier, that this y_predict is a NumPy array and it has various values, right? And it can be considered like a matrices. Let me just give you a simple example of matrice. Just we will be deviating our path for a moment, and I'll go to HandsOn. Okay. So this is a matrix. Okay, matrix is an array of numbers which can be represented like this. For now we have a matrix with just one dimension, and these are called rows and these are called columns. Now we can do mathematical operation on these matrices and the corresponding elements get added. Now in our case we have a single column matrix, right? Only one element is present, and we can have an element wise operation. Another point to note over here is y_test, which was a panda series, and then this y predicted is NumPy array, but underlying implementation for this is NumPy, and we can easily do the mathematical operations, and with the help of matrices we can do arithmetic operation on these bulk of numbers, right? In one go 3 will be added to 4, 8 will be added to 0, and so on. And similarly we can do the arithmetic operation y_test minus y_pred, and all the corresponding elements will have their arithmetic operations. So if I run this, I have one more column added, which is error value. Now what's next? If I want to find the total error by this model, should I be summing it up? Yes, that's the next intuition. But the problem here is these negative values will negate this sum of the values which are we are getting positive value, and we just want to get the error, and we don't which is the delta, and we don't want whether the model told us the less salary or plus salary. We just want what was the error delta, what was the delta, right? And so we don't have to do anything with the minus or plus sign. And for that, what we can do, we know from our school day classes, if we want to have the value only, we can use absolute value. So let's create one more variable and let's call it absolute error. And to find the absolute value, we can make use of NumPy absolute method. And of course, I think I have not imported NumPy so far. So that's again a basic library. Import NumPy as np and we'll run it. So coming back over here, we'll be using NumPy dot absolute method, and whatever value we want to make it our absolute, we have not stored it in a variable, so we'll just pass this over here. And let's run this, and as you can see, we get the absolute value, and now it is easy to sum up the values. Okay, Let's do one more thing to get the magnitude of the error without the sign, and that is squared error. Okay, so we will add so this is getting longer. Let me just put it here. Yeah, so we'll get one more value, that is a squared error. And how do we get the squared error? By squaring the values, and we want to square the difference, right? And NumPy square method comes to our rescue for that, and we will again pass this delta value, right? And then let's run it. So now we have a data frame over here which has predicted value, actual value, error value with the sign, and then we have just magnitude, absolute value, and the square of the magnitude, which is, again, we know that why we have taken out absolute value, squared value, because we don't want that with symbol, and we want to calculate the total error. So now is the time to calculate total error. To calculate the total error, we will sum up absolute error, and we will also sum up squared error, and we will simply use some method of Panda series, and let's store it in this variable app to sum absolute error is equal to, and we will just take this column absolute error, df underscore rec absolute error. Let's just print it, and let's also similarly sum up squared error. So we have these absolute error and squared error, and what I have done, yep, so I need to print this. Yeah, so as we can see, the magnitude of squared error, and as we expect, is definitely much higher than absolute error, right? And then why do we need squared error at first place? We will see. Let's find out the mean. Okay, and we know that mean is the sum divided by total number of elements. What are the total number of elements in this? 1 2 3 4 5 6, right? But we can also use len method, and let's just find the mean, and let's call it MAE. Okay, mean absolute error is equal to sum of absolute error divided by len of df underscore result, and let's just print it. MAE, mean absolute error, and I just give MAE over here. And similarly, to find the mean squared error, MSE, what we are doing, we are dividing the sum by the length of data frame, and which is eventually 6 over here, and we are getting mean squared error. And as we can see, again, the magnitude of mean squared error is quite higher than mean absolute reason, for obvious reason that we squared the values and we summed up them. Let's find one more matrices over here, which is RMSE, also called root mean squared error. And as the name says, we need to make a square root of this is squared error, so this is np.sqrt, and to this we will pass MSE, so root of mean squared error, and let's also print this value. Alright, so let's just print this and run this value. So we have, this is root of mean squared error. So what are these MAE, MSE, RMSE which we have just derived? And these are the commonly used metrics in statistics and machine learning, particularly for regression tasks which we just performed, like predicting salary. Now why these are used as applicable to different scenarios, which we will be talking in detail when we will be doing real life projects. But in gist, this MSE and RMSE, right? MSE is, we are deriving it after squaring the error, and so the magnitude is quite large. So if the error is large, MSE will be quite large, and so MSE and RMSE are very sensitive towards outliers, while MAE is robust towards outliers and depends on the scenario where we need to use what matrices, but these are the ones which are commonly used. And before we say goodbye, we have one thing left over here, and this is what is the final outcome of our linear regression model in the form of visualization, and that will help us to move to our next tutorial, where I'll be diving deep into what is this linear regression all about, how it works. Okay, so let's just make one more visualization. To do that, what I will be doing, PLT, I'll just create a scatter plot between which we have already done, between XY, and let's call it with a label data, and I'll just run it. Okay, so we have already done. We know that this is salary and this is year of experience, and let's also label X and Y for the sake of clarity. PLT.X label, and this time I want to generalize. Instead of saying that those are year of experience or something, I'll just say this is independent variable. And similarly we have PLT.file label, which is a dependent variable. Alright, so we have this scatter plot. Now this is our original data, and what we want to see, what linear regression, how linear regression worked, and what kind of linear relation it derived between the data which we provided, right, unseen data, which was x_ test, and the values which it predicted, which is y_pred, right? So we will draw a line, plt.plot, and we will say x_test, y_predict, and we get a line. Okay, before I explain, let's make it a little differentiate. So I will pass few things to it to customize this line. So I pass the color, I pass the line width, and I pass the label for this. So line 2, which is regression line. Now let's also give title to our graph, plt.title linear regression, and we'll also do plt.legend. So legend indicates what is meant by what in both the graphs. So this is actually blue ones are indicating the actual data points, and this regression line which we plotted between the unseen data which we provided and the label or the value it gave to them. So, and this is a straight line. That means there is a linear relationship between y and test. With the help of this linear relationship, whatever value you give to this years of experience, it will derive the salary for that. And now I think is the time to move to next lecture and to talk about linear relationship between dependent independent variable and how this line is being created. We'll dive into next lecture.